Alrighty, hello everyone, welcome to your pre-lesson video today on circles. So we'll get right into it because we have quite a bit to cover. And the first thing we are going to go over are some terminologies that you would come across very frequently in the unit in circles. Alright, so what is a circle? So a circle is a shape where each point on the shape is the same distance from the center. Alright, as you can see from here to all over, it'll be the same distance. Now, the next thing we have is the diameter. So the diameter, as you can see, it is the distance across the circle through the center, right? And then the radius is actually half of the diameter, and that's actually a really key information for you to remember, all right? And so the radius is the distance from the center to a point on the circle. So as you can see, the radius is half of the diameter. All right. Now a chord, as you can see here, is a segment that cuts across the circle and its endpoints are on the circle, right? So it doesn't pass through the center, but it is a line that does cut across the circle, just not through the center. All right, and so this will be a chord. Now a tangent, as you can see here, is a line that touches the circle at exactly one point right here. And a secant here, right? It's a line that intersects a circle in 2 points. So as you can see, it's like a chord except that it's extended past the circle, right? So it's going to go on and on forever. And that's a secant. All right. Now, a circumference is the distance around the circle. So if you take from this point here all the way around, this is what we would call the circumference. Essentially, it is the entire perimeter of the circle. And it's a special term that we just say circumference. All right. And now an arc, as you can see here, is part of the circumference of the circle. So it's only like part of it, not the entire thing. The circumference is the entire circle. Now a sector, as you can see here, is a pie-shaped part of a circle made of the arc along with two of its radii. All right, and so this entire thing is a sector, and it generally denotes the area of that part of the circle based on its angle, right? So we will actually use this information in next week to find what is the area of this part of the circle. All right, and now with sectors, it can be labeled as a major sector or a minor sector. So a major sector will be like the bigger part of the circle. So for example, this is what we call the minor sector because it's smaller. And then actually, this entire part that's actually not labeled as a sector is what we call the major sector because it has the bigger angle between this and this. All right. Now, segment here is a little bit more specialized towards circles. And so what a segment is, it is the region, as you can see here, that is bounded by an arc and a chord. So this right here is what we would call a segment of a circle. And we will also be able to find the area here. All right. Now the next thing we have are types of circles. So not too bad. So, right. So congruent circles are essentially two circles that have the same radius. And because if they have the same radius, they will be the same size. All right. Concentric circles are coplanar circles with a common center. So remember, coplanar means they are the same plane. And as you can see, all these circles, they have a common center, which is like right here. And they all go round and round and round. And they're all on the like same plane. Okay. Now these two are a little bit more important because you have a lot more questions that commonly come out from here. All right, so an inscribed circle is the largest possible circle that can be drawn inside a regular cyclic polygon. All right, so this will be what we call an inscribed circle because it's drawn inside. And then a circumscribed circle is a circle which passes through all the vertices of any given geometrical figure or polygon without crossing the figure. So as you can see, essentially, a circumscribed circle would have its circumference touching all of the points of a polygon. And this is a circumscribed circle. All right, so think inscribed circle inside, circumscribed circle outside. All right. Now, on to some properties of circles, and the first one we're going to touch on are the tangents. All right. So a lot of questions can come out where they play around with tangents, and they're asking you to find the angle or the length of the line. All right. So we're just going to go through the properties today, and then we'll see how we're going to use all these properties to answer questions during your deep dive lesson. All right. So the first one that we have is the tangent to the circle is perpendicular to the radius of the circle at the point of contact. So look, this is the tangent and this is the radius. So where they meet, which is like right here, we know that it is going to be perpendicular, which means 90 degrees. All right. So if we have like a tangent here and the radius is here, then we know that the angle is going to be perpendicular. All right. So this one's really, really important to know because a lot of questions come out for this. Now, the next thing that we have is if two tangents are drawn from an external point of the circle, then they are of equal length. So if you see here, we have point C, right? So this is the external point of the circle. If we draw a tangent right here and right here, all right, we know that this and this, the two tangents, are going to be of equal length. They are going to be congruent. All right. And then look here, because these two lines are from the radius of the circle to the point of tangency, right, where the tangent and radius meet, we know that this is going to be perpendicular, and these and this will obviously be the same length because it's the radius. All right. So just remember, external point, tangent, tangent, both will have the same length. All right. All right, now with arcs, central angles, inscribed angles, and chords, a lot of questions also come out about this, so do remember all of these properties. All right, so I'll go over the definition of what a central angle and an inscribed angle is first. So the central angle is the angle subtended by an arc of a circle at the center of a circle. So essentially, like here is what we would call the central angle because it is at the center, because it is the angle at the center of the circle. All right. Now, an inscribed angle is an angle whose vertex lies on the circumference of a circle while its two sides are chords of the same circle. So if we look at this example, this here, because this angle lies 1 on the circumference of the circle, 2, its lines are made of the chords of the circle. This one here will be what we call the inscribed angle. And then this one here, as you can see, because it's at the center of the circle, this is our central angle. All right. Now, onto the properties. So the first one that we have is the measure of the central angle is equal to the measure of its intercepted arc. So because this is the arc of this central angle, we know that if this central angle is 140 degrees, then that means this arc would also have a measure of 140 degrees. All right, so center, if angle is center, arc will be the same. Now, on the other hand, the central angle subtended by 2 points on a circle is twice the inscribed angle subtended by those points. All right, so that means this is going to be double of this. So if you're ever given a question where they give you this, you're just going to multiply this number by 2 to get the central angle. And vice versa. If you're given this and you are asked to find this, you would just take this number and divide it by 2 to get this angle. All right? Now, the next thing that we have is the arc addition postulate, which just essentially tells us that the sum of a major arc, so in this case arc BAC, and if we add it to the minor arc, which in this case is CB, it's going to be 360 degrees because the total angle in a circle is 360 degrees. All right, so as you can see, arc BC plus arc BAC equals 360 degrees. So this one is just really, really helpful to remember. All right, now here, incongruent circles over the same circle, if two arcs are equal, then their chords, so in this case here and here, are equal, right? Because of the measure of angle. All right, so just remember, arc is the same, arc is the same. That means chord is the same, chord is the same, chord is the same. All right, so this is the chord. So from here we can tell that AB equals to PQ. So this one is just really, really helpful to remember, because we would use this to find the parameter of the the inside shape, the inscribed shape, or the area of the segment. All right. Now, if a diameter, so this is perpendicular to a chord, then it bisects the chord and its arc. So that means this is equal and this is equal. All right. So as you can see here, because UT, which is the diameter, bisects chord QS, QR would equal to RS, and measure of arc QT, supposed to be there, but you know, okay. But measure of arc QT would equal measure of arc ST, and same thing that we can say, the measure of arc QU would be the same as the measure of arc SU. All right, there we go. So this one's also just another really good one to remember. Now the same thing. In the same circle or congruent circles, if two chords are the same distance, right, from the center of a circle, then the chords are congruent. Now, like I said, because chord AB and chord CD are the same distance because of this, are the same distance from the center of the circle, that means these two chords are going to be congruent. They are going to be the same length, right? So as you can see here, if OP equals OQ, then AB equals CD. All right? Now the next thing that we have is the angle subtended by the diameter of a circumference is a right angle. All right? Because this is the central angle, and this is the inscribed angle, right? So if we look here, if AB is the diameter, then angle ACB, so this angle here, is 90 degrees. All right, it's a right angle. Next thing that we have is the angles subtended at the circumference, so here and here, by the same arc, are equal. All right. So what this means is that angle ACB would equal to angle angle ADB. So that means this angle here and this angle here are going to be the same. All right, because they are on the same part of the arc. This one. That's why these two are also the same. All right. Now, another thing that we have is two equal chords subtend equal angles at the center of the circle. So as you can see, because these two chords are of equal length, if we were to draw these lines, we know that these two angles are going to be equal, because if you remember geometry, right, in your earlier lessons, these will be what we call vertical angles. All right, that's why they are equal. So as you can see, angle AOB is equal to angle COD. These two angles are equal because the chords are the same. All right. Now, if a quadrilateral is inscribed in a semicircle, then its opposite angles are supplementary. So what this essentially means is that angle C and angle E would equal to 180 degrees if you add them together, and then angle D plus angle B, when you add them together, would equal to 180 degrees. And so we will use that information again to find the angle at certain points of the shape, right? Alright, on to the last thing that we have for today is the measure of an angle formed by a chord and its tangent is half the measure of the intersected arc. So if we look, if angle DBA, it is going to be equal to half of measure of arc AB. Alright, so let's say we know that the measure of arc AB is 100 degrees, right? So that means measure of angle DBA is going to be 50, right? Because this is 100. This is going to be half of it. So we're just going to do 100 divided by 2 to get this, which is 50. Alright, and so we would use this information to be able to find either this or this, given that it's a tangent and a chord. Alright? Alrighties, and that is it for today, guys. Thank you for tuning in. As usual, if you have any questions, send me an email or bring it to your deep dive lesson. Alright? Have a good rest of your day.